Getting familiar with the Terraform loop. For the remainder of this lecture, we will be using a Mac to complete the exercise. In this exercise, you will learn how to run the basic Terraform loop in Azure. There are 4 components of the Terraform loop. Init, for initialize the local Terraform environment, usually executed only once per session. Plan, compare the Terraform state with the as-is state in the cloud. Build and display an execution plan. This does not change the deployment, it's read-only. Apply applies the plan from the plan phase. This potentially changes the deployment. Destroy destroys all resources that are governed by this specific Terraform environment. This lecture assumes that you have created an Azure account and subscription. If you haven't, please see the assignment previous to this one. The first thing we will do is install the Azure CLI tools and configure it to be used with Terraform. Install the Azure CLI tool with brew. Brew update & brew install Azure-CLI. You will use the Azure CLI tool to authenticate with Azure. Terraform must authenticate to Azure to create infrastructure. In your terminal, use the Azure CLI tool to set up your account permissions locally. Type AZ login. You now have logged in using your account you created in previous lectures. In the output in the terminal, find the ID of the subscription that you want to use. Once you have chosen the account subscription ID, set the account with the Azure CLI. Next, we create a service principal. A service principal is an application within Azure Active Directory with authentication tokens Terraform needs to perform actions on your behalf. Update the subscription ID with the subscription ID you specified in the previous step. The output includes credentials that you must protect. Be sure that you do not include these credentials in your code or check the credentials into your source control. For more information, see the assignment details. Next, you need to set your environment variables. HashiCorp recommends setting these values as environment variables rather than saving them to your Terraform configuration. Input the values that were outputted from the previous command. Great, we are all configured to use Azure now. Next thing we're going to do is install Visual Studio Code. Next, in the terminal, we will issue the following commands to create a directory that will contain our Terraform configuration. And open up a file for main.tf. Now we need to write configuration to create a new resource group. See the assignment detail to copy and paste the code snippet. Note, the location of your resource group is hard-coded in this example. If you do not have access to the resource group location, update the main.tf file with your Azure region. This is a complete configuration that Terraform can apply. In the following sections, we'll review each block of the configuration in more detail. Terraform block. The Terraform block contains Terraform settings, including the required providers Terraform will use to provision your infrastructure. For each provider, the source attribute defines an optional hostname, a namespace, and the provider type. Terraform installs providers from the Terraform registry by default. In this example configuration, the Azure RM provider source is defined as HashiCorp/Azure RM, which is shorthand for registry.terraform.io/HashiCorp/Azure RM. You can also define a version constraint for each provider in the required _providers block. The version attribute is optional, but we recommend using it to enforce the provider version. Without it, Terraform will always use the latest version of the provider, which may introduce breaking changes. Providers. The provider block configures the specified provider, in this case Azure RM. A provider is a plugin that Terraform uses to create and manage your resources. You can define multiple provider blocks in the Terraform configuration to manage resources from different providers. Resource. The resource blocks to define components of your infrastructure. A resource might be a physical component such as a server, or it can be a logical resource such as a Heroku application. Resource blocks have two strings before the block: the resource type and the resource name. In this example, the resource type is Azure RM _resource _group, and the name is RG. The prefix of the type maps to the name of the provider. In the example configuration, Terraform manages the Azure RM _resource _group resource within the Azure RM provider. Together, the resource type and resource name form a unique ID for the resource. For example, the ID of your network is Azure RM _resource _group.rg. Resource blocks contain arguments which you use to configure the resource. The Azure provider documentation documents supported resources and their configuration options, included Azure RM _resource _group and its supported arguments. Initialize your Terraform configuration. The Terraform commands will work with any operating system. Your output should look similar to the one in the assignment text. Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. If you ever set or change modules or backend configuration for Terraform, rerun this command to reinitialize your working directory. If you forget, other commands will detect it and remind you to do so if necessary. Format and validate your configuration. We recommend using consistent formatting in all your configuration files. The Terraform FMT command automatically updates configurations in the current directory for readability and consistency. Format your configuration. Terraform will print out names of the files it modified, if any. In this case, your configuration file was already formatted correctly, so Terraform won't return any file names. You can also make sure the configuration is syntactically valid and internally consistent by using the Terraform validate command. The example configuration provided above is valid, so Terraform will return a success message. Success, the configuration is valid. Apply the Terraform configuration. Run your Terraform apply command to apply your configuration. This output shows the execution plan and will prompt you for approval before proceeding. If anything in the plan seems incorrect or dangerous, it is safe to abort here with no changes made to your infrastructure. An execution plan has been generated and is shown. Type yes at the confirmation prompt to proceed. Terraform will perform the action of creating a resource group. Navigate to the Azure portal in your web browser to check to make sure the resource group was created. Inspect your state. When you apply your configuration, Terraform writes your data to a file called terraform.tfstate. This file contains the IDs and properties of the resources Terraform created so that it can manage or destroy those resources going forward. Your state file contains all of the data in your configuration and could also contain sensitive values in plain text, so do not share it or check it into source control. For teams or larger projects, consider storing your state remotely. Remote state storage enables collaboration using Terraform, but is beyond the scope of this exercise. Inspect the current state using Terraform show. When Terraform created this resource group, it also gathered the resource's properties and metadata. These values can be referenced to configure other resources or outputs. To review the information in your state file, use the state command. If you have a long state file, you can see a list of resources you created with Terraform by using the list subcommand. If you run a Terraform state, you will see a full list of available commands to view and manipulate the configuration state. This command has subcommands for advanced state management. These subcommands can be used to slice and dice the Terraform state. This is sometimes necessary in advanced cases. For your safety, all state management commands that modify the state create a timestamp backup of the state prior to making modifications. The structure and output of the commands is specifically tailored to work well with the common Unix utilities such as grep, awk, etc. We recommend using these tools to perform more advanced state tasks. Terraform destroy. Lastly, issue the Terraform destroy command to complete the lifecycle and undo the changes that you have made. Terraform keeps a state of the changes you made in the Terraform state file so it knows exactly which ones to undo.